Good afternoon. Oh, it's actually still morning. Still morning. Good morning, good morning, good morning. Happy Wednesday. Wonderful Wednesday. Alrighty. While folks are coming in, make sure that you have turned in your worksheet from the other day. I'll pull it up in a minute. Then we're going to go on and talk about pedigree today. Actually, before we talk about pedigree, we're going to go ahead and look at the sex-linked worksheet. So you have a worksheet that is in. We'll look at pedigree next class. Okay. Let me first of all make sure it's in the module. And I think it is. It is. All right, so we'll look at it from there. And actually, I did have somebody come to tutorial yesterday, so I did answer a few more questions on the worksheet. So let me look at that first. We'll come back to the one for today. All right. So, okay. So I did questions 4 and 5. So if you want to take a quick look at what your answer should have been for 4 and 5, if you haven't done it already. And again, this constitutes review because we are doing the midterm test for you all for next Friday. So midterm exams next Friday, and it's going to cover everything from January. So that's genetics and cell reproduction. And that's mostly because they go hand in hand. So we probably won't get to karyotyping before the test, but we will after the test. But we will get to pedigree. All right, so got a couple of people coming in. Still missing somebody. All right, so again, if you haven't turned in your worksheets yet and you're still trying to scratch your head, I did questions. I had done up to 3 before. Now I've done 4 and 5 for you. So in dogs, long hair is dominant. So we're using capital L. Short hair is a lowercase l. They are crossing a heterozygous long dog. And again, the vocabulary, it's important that you understand your vocabulary so that you can read these problems, because that's how these problems work. They give you the terminology and you have to translate what that means. Heterozygous long-haired dog means that they do not have, the alleles are not the same. So you have one dominant, one recessive, and they're being crossed with another dog that is long hair, but also heterozygous. So both of them are capital L, lowercase l. And you write the little X in the middle that represent, this is who we are crossing. Gametes, we separate them and put them in the boxes at the top and the bottom, and then we fill in the boxes. All right, so this one would be capital L, because it's this box and this one. This one is a lowercase l with that one, so that's capital L, lowercase l. This one up here with this one on the bottom, again, capital L, lowercase l. This one at the top with this one on the bottom, two lowercase l's. So then we look and we translate that. So this is 4 possibilities that we can get if these two heterozygous dogs mate. Okay? We can get 1 homozygous. There's our last person. We can get 1 homozygous long-haired dog. So I'm reading the box. You got to read the boxes first. And then the second, these two over here are alike. So there's 2 heterozygous long-haired dogs. And this box is all by itself. There's 1 homozygous short-haired dog. Okay, so when we look at the genotypes, these are our genotypes up here. We have 1 to 2 to 1. Okay, 1 homozygous long, 2 heterozygous long, and 1 homozygous short. Phenotype is what it looks like, so we stop looking at whether it's homozygous or heterozygous, and we just want it's long-haired or short-haired. There are 3 of them that are long-haired and 1 that is short-haired, so your ratio is 3 to 1. So you got to write your ratio. It wasn't enough to tell me this over here. You got to write it as a ratio, like in math. All right, next question was a little tricky because it asked you, it didn't tell you who the parents were, but it told you what the result was. They said if yellow is dominant over white kernels, and you crossed a yellow pea pant was crossed with a white pea pant, so you know that the white one had to be 2 lowercase y's, but they're asking you what did the yellow plant have to be if 50% of the offspring have white kernels. All right, so up here on the top, to get 50, so that one might have been where you filled in the boxes first. In order to get 50% yellow, the 50% white, the yellow parent had to have a allele for white. Okay, so they had to be capital Y, lowercase y. And then we already knew that this one was going to be 2 small y's because that's the only way we could get 50% white kernels. Okay, so again, 50-50 or 25-25. And again, if you say 50-50, that's not wrong either. Because this is 100% in this box, like I had over here, 100%. Each one of these boxes is 25%. So 2 to 2, and phenotype is 2 to 2 because we had 2 white and 2 yellow. Okay. All right. Hopefully you finished the others on your own. Turn that in because that's now late. All right. Or today it is. All right. Today we are going to look at, and I'm going to have to stop sharing in order to get back to that. Today we're going to look at sex-linked characteristics. And that worksheet is in your module. And that's a little different because we're not only are we going to do the box, but we have to put little tags on the chromosomes. All right, so that's where everybody should be. Okay, so it's in the module. Let me go back. It's in the module. And it should also be on your desktop, right up underneath inherited types of inheritance. One of the types of the inheritance was sex-linked traits. So we're going to look at how do we, because we label them a little differently than we do the other ones. The other ones we were just dealing with 1 letter. Now we're dealing with 2. Okay. All right, I was trying to, I think I did this on a Canvas board. All right, so they're giving you, so read the paragraph and look at the information that they're giving you. So they're telling you that certain characteristics are carried on the X or Y chromosomes. Mostly the X chromosome is usually shows up, and it's usually a recessive characteristic, meaning if it's not on the Y chromosome cannot mask it. Usually recessive characteristics can be hidden because the other chromosome will mask it. There's nothing to mask this, so they show up. All right, so read this over, and I'm going to pull up where I started to do it already on a Canvas board. Because it won't let, this is a PDF, it won't let me write on it. And I can't do what y'all do. I don't have Cami, so I can't do it like that. So I had to do it. All right, so I have question number 1 already done for you.
Question.
Mm-hmm.
For the assignment that's due today, do we draw out the Punnett square?
Yeah, remember I showed y'all how to do that. Let me show you again.
Yes, please.
Okay, let me go back.
Because I filled it out. I just don't think I drew out the Punnett square. I forgot about it.
Okay, yeah, you gotta have a Punnett square. That's one of the 5 things it asks you to do. So, and I'm gonna do this up at the top of the worksheet because it's gonna shift everything. All right, shoot. All right, so mine is up as a Word document, and I'm not sure how y'all are pulling yours up, but you should be able to go up to insert a table. And I think that's what this is. So let me just delete that. Delete. Delete the whole thing. All right. So I'm going to do this again. All right. So again, you have to have all 5 pieces of information for all these questions. Again, the gametes are represented by putting the letters in the individual boxes. So other than that, you have written the parents' genotypes. Okay. All right. So I came up to insert on mine. Oh no, do it like this. All right. So I'm up here at insert, and I selected table. And then I wanted to have 3 rows and 3 columns. All right, and then you can make it smaller. I go like that because it doesn't need to be that big, or you can leave it alone. It doesn't matter. I just thought mine was huge, so I like it smaller. All right, and then you can put your one parent across the top, the other parent across the side, and then you have these 4 boxes to fill in the rest. So I think, all right, okay. All right, and you needed to have one of those for each question. So each question should have a box, a Punnett square box. All righty. That being said, let me go back to the one for today. So for today, we're doing the sex-linked one. So you have that one pulled up. I did it on Cami because I couldn't write on my worksheet. So I produced the question and the box. And I've already filled it in. Maybe I shouldn't fill it in. I can actually. All right. So the question says that if you're looking at the key, and I wish I had them side by side. Wait, give me a minute. Maybe I can pull that up here too. Give me 1 second to make that happen. Okay. Mm, okay. All right, so I'm going to put this information. So this is your information key for answering the questions. Copy. And then guess while I have it up here, I'll do number one. So based on this information here, they're telling you that if you have, in order to have your X and your Y chromosomes cell, whether you are male or female. All the other ones, like we talked about yesterday, are autosomes. So those are what all the rest of the cells in your body have. But the gametes also have X and Y chromosomes. Okay. Those chromosomes have certain characteristics on them that none of the other chromosomes have. So that's why we call them sex linked. They are only found on the X or Y chromosome, typically the X chromosome only. Okay. And you need two alleles like everything else from each parent, except this time you get one X from mom, you get the other X from dad. Okay. So if you get an X from mom and an X from dad, you're a girl. If you get an X from mom and a Y from dad, you're a guy. All right. So this one is showing the key is saying that normal hemophilia is where you cannot clot, your blood doesn't clot. Okay, if you have this condition, they have to rush you to the hospital because you could bleed to death. Because when you get a cut, you'll just keep bleeding. It won't clot. All right, so capital H is saying that it's normal. They do not have hemophilia. So we're going to have an X chromosome with a H tag on it to say that this is normal. The second X doesn't have to have anything on it, and you're normal. Okay. This second one on here has a lowercase h. The lowercase h is because hemophilia is a recessive characteristic. Okay, so we're going to write it like that. So if one H, if one X has the lowercase h and the other one does not have anything on it, then this person will have hemophilia. Why? There's no H on either one of the Y, so they don't have hemophilia either. Okay. And you usually don't have YY because the guy has to have an X. But they're just trying to show you that there's no hemophilia at all. This one also is, now they're writing B for colorblind. So if you have normal vision, you're going to have the capital B on the chromosome. Lowercase b says you're going to be colorblind. That means you don't see certain colors. On the Y's, there's no allele for color blindness on the Y, so they also will not have that. All right, so a normal male will be X with a capital, for this one is just XY. They just want to know what actually no, it says write the genotypes of the phenotypes for color blindness. Okay, color blindness. We're going to use B. So you're going to have an X with a capital B. And you need to write this because I can't write on the thing. X with a capital B and a Y with nothing on it. And this person will be normal. Capital B is normal. So they will not be. So next to that, you write not colorblind. Okay. So the genotype was X, capital B, Y. That's the genotype. And then you have to say not colorblind. That's the phenotype. Next line, it says a female carrying no colorblind alleles. They're homozygous. So they're going to have XX, but carrying capital H's. They are not carrying a colorblind, sorry, capital B. Oh, X with a capital B and another X with a capital B, and then write not colorblind. So their genotype is XX and both tagged with a capital B like they have up here. Not colorblind. All right, a colorblind male is going to be X with a lowercase b and a Y. X with a lowercase b and a Y. And then next to that, you write he is colorblind. Well, you don't have to say that because they already tell you that. But all right, a normal female carrying the colorblind allele. Okay, so she is going to have one X with a capital B, and her second X will have a lowercase b. She is not colorblind, but she's carrying the gene for colorblindness. Okay, again, two X's, one with a big B, the second one with a lowercase b, and she is not colorblind. And then a colorblind female, which doesn't happen often, you're going to have two X's, and both X's will have a lowercase b. Okay, do I need to repeat any of those? Okay, all right. So, all right, so what I did for the first one is I did that on my Canvas project here. Yay. All right, so they gave you this information for number one. You have two X's, so the female here is normal for color blindness. She's not colorblind. Both her alleles have a capital B, and they're being crossed with the male or mated with the male that has color blindness because he's carrying his X has a lowercase b, nothing on the Y. Okay. And then the question is asking you what percentage of male children are colorblind and what percentage of female children are colorblind. So then we put the female up here. She's got X capital B, X capital B, the male over here, X lowercase b, and Y with nothing on it. And then you do what you did before. You take the top and the side and you put that in the first box. Then the top and the side, put that in the second box. Top and side, top and side. Okay? All right. Then we have to read what's in the boxes. So up here on the first row, we have two females, and they are carriers, but they're not going to be colorblind. So we need to say that. So as far as, let's see, the female question, this is what percentage of females are going to be colorblind? 0. Okay, because they're not colorblind. They are carriers, but they're not colorblind. All right, what percentage of the males are colorblind? Both of these X's are capital B, so they are also not colorblind. So 0% of the males are colorblind in this part of the question. Okay, and that's possible. Nobody's colorblind. Everybody's got good vision. All right, let me hop back to the worksheet. Not that one. Where is it? All right, give me a minute to find. There we go. All right, so that was part A. Part B says what percentage of, okay, that's all questions. So that answered both parts of this. So you need, on your worksheet, you need to fill in the box like I did, put the letters on the top and the side since they've already drawn the boxes for you, put the gametes on the top and the side and fill that in. I'm going to try to do this one for you as well. Copy since we only have a few more minutes. Okay, so let me see. Can I move this? Are you gonna move for me? No. Go back. There we go. Where there's a will, there's a way. All right, then down here. Not there, here. Okay. And then I want that over here. Okay. And then I want to do the same thing here. I want to move that. Yep. Move that there. All right. And we're just going to ignore the box that we don't need to use. All right. So this one, they tell you that you have X. So we're still looking at color blindness. So we're going to put the female up here in this box. X, B, and I'm going to make that bigger so that we can actually see it. Come on. Okay. And then the other allele is, so now we're taking the offspring. Lowercase. All right, and we're crossing that with the male. So we're taking the offspring, one of the offsprings from the question 2, and we are mating those. So capital B. And Y. Okay. All right, so again, in this box, we got the top and the bottom. So we're going to get a little different result this time. Capital B, capital X, capital B, because we just did these two. And this one is going to be capital X, capital B, capital X, lowercase b, because we're going this one with this one. All right, so down here, and notice when we do male and female, it's always 50% male, 50% female, but it's what's going to be on those genes is going to be different. So in this box, we got capital B and a Y. Oops. Okie dokie. And over here, we have, oops, yeah, we have X, lowercase b, and a Y. Okay, so now we got to read what's in the box. Okay, and I forgot to put them. I don't know. All right, so this first box has 2 capital B. That's a girl who has normal vision. Second box, this is also a girl. She's a carrier. She's heterozygous for normal vision, but she's still not blind, colorblind. Okay, so they're both. So if they ask you for the percentage of females that are colorblind, it's still going to be 0. Okay, neither one of those young ladies is colorblind, but she's a carrier. All right, down here for the males. This one has a capital B, so he is not colorblind. But this one is because it's got a lowercase b. So as far as percentage or portion, you can say 25%. of the males will be, and then it's 25% of the offspring, but as far as the males, there's two ways you can say this. It's 50-50 as far as having a male or a female, and half of the males will be colorblind. Okay? That's the way you can look at this. This one has normal vision because it's got a capital B. This one is going to be colorblind because there is nothing to hide that recessive gene. This one at least has, this female has a capital B to hide that recessive gene, so we won't see color blindness. This one has nothing to hide that recessive gene, so they will be colorblind. All right, everybody get that? All right, we got a few minutes left. I'm going to let you do the next one on your own. But everybody should have the first couple of questions done because I did them for you. Okay. So question 1 to 3 have been answered. You just have to do 4, 5, 6, 7, 8, 9. And we'll worry about these later. Okay. Actually, we'll still be doing this tomorrow. Tomorrow, I see you Friday. So Friday, we'll finish this up, but at least try to get 2 more done before it's time to go. Okay. Let me put that over here. Real nice. I will do that one for you too. Oops. Okay. A colorblind woman. All right, so that means she is X with a lowercase b, because in order for her to be colorblind, she's got to be carrying both of the recessive genes. She is colorblind. I'm only doing this because I like y'all. Otherwise, I'd let you do it by yourself. Alrighty, and we have a male who is normal. That means he's got X and a capital B. He is not colorblind. All right, you see why knowing the vocabulary is important? Because you have to interpret the words. I know how to draw this because I know what this is telling me. All right, so the woman is colorblind. She marries a man who is not colorblind. They want to know what is the probability that they're going to have any children that are colorblind. So let's work this out. X lowercase b and X with a capital B. And I could have written that the other way around, but I took the top and the bottom first. All right, so we got one female. She's not going to be colorblind because we got that capital B. So Dad saved her on that one. All right, and we got this female. I'm going to write it the correct way. Who's also going to inherit the normalness from dad. So she also is not going to be colorblind. However, the boys are not going to be so lucky. All the boys are getting X lowercase y from mom. So that's one boy that's colorblind. And the second boy will be also. Okay. All right, so what you were to put on the lines up here, let me finish doing what I'm doing. All right, so up here, you should have written what I had down there. Can I write on there? X, no, it's not letting me write in the box. Right in the box. Yes, it will. All right, so mom is colorblind and dad is not. All right, so that was what you should have had up on that line. And I guess you can say the answer to the question is I spelled that wrong. All right. Is it actually percentage of children? You can say 50%. Okay. All right. So again, we'll finish this up on Friday. It's time to go pretty much. Any questions? Anybody totally confused? You got it? All right. Have a good lunch. See you Friday. Oh, I didn't do attendance, but everybody's here. All right, I'm gonna stop sharing so I can do attendance. Thank y'all for all being here. And again, I gave you the answers to that, so there's no reason not to have those done on your worksheet. I'm coming. That's what it's telling me. I understand. I understand. I totally understood everything she said.